All right, folks, here we are, another exciting video lesson for math. This one is on how to solve using the process of elimination. We have done this again in Algebra 2, but I just want to go through a couple examples to refresh your memory, and you can always watch the hand teach if you want to watch that as well. This is Chapter 7, Day 2. So basically what we're trying to do here is not have to use substitution. The first example in the packet, which is the examples I'll be doing with you quick today, in this first problem, trying to get something alone so that I could use substitution would be problematic because I'd have to divide by these numbers and have a bunch of fractions. So sometimes it's easier to use what we call elimination, which is exactly that. You're trying to eliminate one of the variables. So what you need is you need an equal but opposite pair of x's or y's. So, for example, in this problem, I don't have to do any work because I already have this pair of y's that are equal because they're both 2's but opposite since one's positive and one's negative. So they will, what we usually call cancel out or eliminate. That's why it's called elimination. So this, I'm basically adding these columns together. So this column becomes an 8x. This column cancels or eliminates because they're equal and opposite. And this column is a 12. And so I'm going to have, no, it's not a 12, it's a 16. So I'm going to have 8x equals 16. Now I just need to solve for x by dividing by 8, keeping in mind that what you're trying to do here is still find an ordered pair, an x and a y, that make both of these true, meaning where would those lines cross? And in this case, it's telling me that the x value for that point is a 2. So now I have to take that 2 back up here, and you can choose either one of those equations to plug it into. So whatever one you think is going to be the easiest. I'm just going to go ahead and put it into the top equation, and keeping in mind that I found x first, so I'm plugging it into the x spot. Sometimes you'll find y first, and you got to remember to plug it into the y spot. So here's 6 plus 2y. Now I'm subtracting the 6 from both sides, and so if I do that, this is going to give me a negative 2, and then dividing by 2, the y will be negative 1. And so if I was going to win $1 million for getting this right, I can plug that back in and just kind of test. Does 3 times 2 plus 2 times negative 1 actually equal 4? Why, yes, it does. Then you check in the other. Does 5 times 2, which is 10, then here, this would turn into a plus 2. Does that equal 12? Yes, it does. So that makes 2, negative 1 the solution for that, keeping in mind that sometimes you have one solution. In fact, that's most of the time. But sometimes you get no solution, meaning those two lines don't cross, they're parallel. And sometimes you get an infinite number of solutions, meaning that those two lines are actually the same line. So what if they don't give you a matching pair? What can you do about that? So the next example that I have on this packet notes page is this. So if you don't have an equal but opposite pair, the only thing you can do is multiply. So multiplication is your only tool. So that means that you can multiply one or both by a number that will make them add up. And so in this case, I can get these two to equal each other by multiplying the top by a 2. But because I need them to be opposite, I'm actually going to multiply by a negative 2. So the top equation, when I distribute this, will become a negative 4x. The negatives cancel into a positive 2y. And then don't forget about that guy. I get equals negative 2. And then my bottom equation, I didn't do anything to, so it stays the same. So I got what I wanted in my x's. I got an equal but opposite pair. So these now cancel, leaving me with nothing. But what sort of is an unintended consequence in this particular one is this also cancels. So this side has nothing left. But what's extra weird is this side also cancels, a negative 2 and a positive 2. So don't get panic struck by that situation because this is always true. 0 equals 0, 5 equals 5, any true statement, that is the way that you know that this one has an infinite number of solutions and that if you really were bored and took the time to graph them, those two are the same line. So we came into that situation, with substitution sometimes, and this is what that situation would look like using elimination. All right. So the next one on that packet is super messy decimals. So we're just going to skip that for now because it just makes it super complicated and probably will confuse us more than help us. So let's jump to this example that you'll see on there as well. And again, I need to create a pair that's equal but opposite. And I can do that in a couple of ways. What if I want these two to match up? My only tool is multiplying, so I'm going to multiply the top by 2, and this time I'll use a positive, so this will become a positive 2x, and we'll cancel with this negative 2x by having an equal but opposite pair. So I'll distribute, not forgetting that last guy. I'll get 2x minus 4y equals 6 in the top row, and then I didn't do anything to the bottom row, so that's going to stay the same. So again, these two are equal but opposite, but so are these. So I have nothing left on this side, and these combine to get 7. Well, obviously 0 doesn't equal 7, so anytime everything's dropped out, your x's are gone, your y's are gone, and you have a false statement, that's where you know there's no solution. And again, if you're super bored and you graph these would be parallel lines. So they never cross, and therefore they don't have an xy coordinate that works as the solution. Let's tackle that last one on here, and then hopefully that's a good enough reminder of how to do these so that you can be successful. Keeping in mind you're doing IXL I6 under pre-calc and also I7, which is word problems, and that can be tricky. So hopefully we'll get a conferencing tool in the next day or two so I can help you set some of those up. Otherwise, I'll put some online or do a few on another video for you. So the last example that I want to tackle is this one at the bottom of the page. And in this case, it looks to me like you can always choose whatever's going to make it easier. To get these two to match up, I'd have to multiply the top by 5 to make it a 10, and then the bottom by like maybe a -2 to make it -10. But my easier pair to match up is going to actually be these, because if I just multiply the bottom by 4s, this will turn into a 4y and cancel my -4y. So making that decision, the top would stay the same. I'm not doing anything to the top. And then as I distribute, the bottom will have a 20x, a +4y, and a -4. Now I do my combining. These combine to be 22x. These cancel or eliminate. And then this is going to give me a -11. So when I go through now to divide by 22, this actually ends up being a -1/2 as my x value. So that's not awesome, but at least it's still a reasonable answer. Now I do have to go back and plug it in. I'm going to go back to something that looks easy-ish, I guess. I think it doesn't really matter, but I'm going to go ahead and plug it into this last one. So I'm going to plug it into the first one. It looks a little easier because I'll be taking 2 times that -1/2, and so in that way the fraction will actually cancel. And then I have -4y equals -7. So now I have this, and I've kind of gotten rid of that fraction for now. Adding 1, be careful because you're going to want to have an 8, but you actually don't get an 8. You get a -6 over here. And so then when I divide by my -4, y equals -6 divided by -4. The negatives cancel, and it reduces for a y value of 3/2. So if you're using your calculator and you're not a math teacher and you don't love fractions, instead of -1/2 and 3/2, you might have a -0.5 and a 1.5. And either way, when you plug them back in, if you wanted to check, you'd be able to find out that was correct. So elimination is just another way to solve when getting an x or y alone is kind of problematic, or when you're forced to do it that way. So on I6 in the IXL, it's straight up just solving, and take your time because every one you get wrong, makes you go backwards. But when you get to I7, that's going to be word problems. So the tricky part there will be setting it up. Solving it is just going to be like I6. So hopefully this helps you get through I6. And then if we can't, like I said, get a conferencing tool up and running in the next day or two, I'll make sure to post some examples of word problems to help you get those set up. So I6, I7, and then there's the combined substitution elimination worksheet that's online. And that's all, kind of due by the end of the week. So look through your due dates. Take care. See you soon, I hope. Bye-bye.